Hello, this is a supplementary math lesson for Algebra 1, Lesson 80.A in your textbooks on page 287. This video assumes that you've watched the previous video for Lesson 79. If you haven't, you might want to go back and watch that one first, because I'm going to be mentioning things that I went over in that video. So this lesson, is a continuation in those same type of word problems that I said Mr. Saxon is so fond of, and here's another variation of those right away. And so the variation is, instead of solving for consecutive integers along the number line, 1, 2, and 3 would be consecutive integers, we want to solve for consecutive odd or consecutive even integers. So let's just think about that. Okay, in the case of even integers, we said there's two things to keep track of in the problem. How do we express the unknowns? Okay, the three integers we're solving for, we're going to express them in terms of the very first one. So we only have one unknown. Okay, and then the second problem in these word problems is deciphering the language so we can write the equation. Okay, so let's just look at the first step of that. How do we express the unknowns in these word problems? Well, you'll notice if we still use n to denote the first integer that we're going to solve for, in the case of this, let's say that it's 2. Okay, 2 is an even integer. We want the next even integer down the number line, which would be 4. Okay, so remember, n is always going to be our starting point. It's always going to be the first number in the series. It's going to be the number furthest to the left in our number line, because then we read to the right. We add to the right to get the other consecutive integers. Okay, so if our next even integer is 4, we can express that as n plus 2. The original number, 2 plus 2, would equal 4. And likewise, the next one down would be n plus 4, because we're expressing it in terms of the original number 2. 2 plus 4 is 6. So see how we do that? Interestingly enough, if we use it for odd integers, and again, this applies to both sides of the number line, negative or positive. Okay, if we use n for an odd integer, say -5 way over here, the next one to the right of that, the next odd integer would be -3. So -5 plus a 2 would be -3. The next one in line would be -1. Okay, that third odd integer would be expressed as the first one, -5 plus 4. That would leave a -1. So we notice right off, if we're expressing consecutive odd or even integers, we're going to use the same expression for the variables. It's going to be n plus 2, n plus 4, and continuing on down the line, whether the integers are odd or even, whether they're on the negative side of the number line or the positive, the same holds true. And if we have more integers, as I've indicated here with the dash, that they want, we would continue expressing the unknown in the same way. The next one in the line, again, would be n plus 6. Now notice, if it were to happen in this case, it would actually hop over the 0 mark to our positive side of the number line, because our original number would be -5, plus 6 would be +1. And that's okay. That's the next odd integer on our number line, but that just might occur in some of those problems. It actually hops over the 0 mark, and it changes from a positive number in the line to, or excuse me, a negative number in the line to a positive one. So that might be the case. Okay, so that's the first thing to keep track of. And so you need to pay attention, because this happens all the time in all the classes I had that this word odd and even with the integer. They're small words. They're easy to skip over in the word problems, okay? I'm going to be working off of page 287, the examples, starting there. If you want to pause the video and turn to page 287 in your workbook, do that right now. Okay, so I'm going to do example 80.1 at the bottom of page 287, and it says find 3 consecutive even, there's the word, the key word we're looking for, even integers such that the sum of the first and the second equals the sum of the third and minus 10. Okay, so we want 3 consecutive even integers. Okay, so our variables are going to be expressed as n plus 2, and n plus 4. Okay, now let's get into the word problem. Find 3 consecutive even integers such that the sum of the first and the second, okay, we're going to be adding the first one, which is n, and the second one, n plus 2, and again, I would recommend for these follow-on terms, keep your parentheses for right now. In the next example, I'll show you how that's important, okay? And then that will help us avoid problems, but let's just keep writing the equation from the word problem. Okay, such that the sum of the first and the second equals, there's our term, equals the sum of the third and minus 10. So we have another sum, and what is it? It's a sum of the third number, n plus 4, and this case a number, minus 10. Okay, now that we have it written out, okay, we can look at our parentheses. Okay, it's no harm in taking the parentheses away. There's nothing to accomplish on the inside or the outside that would change that. So it'd be n plus 2 equals, and we look again here on this side. Okay, we can take away that parentheses, and let's combine these signs right here into a minus 10. Okay, so then what we're going to do is we're going to combine the n's on this side, the left side, and the numbers on the right side. We'll have an n plus an n is a 2n, and then we're going to bring this n over to the other side by subtracting it over here. So we'll have a 2n minus n, that will leave an n. Okay, and I'm going to combine the numbers over here on the right side. I've got a minus 10, I've got a 4, that gives me a minus 6. I'm going to subtract a 2 from this side. I'm going to subtract a 2 from this side, which I already had a minus 6, so that will become a minus 8. Okay, I hope that didn't confuse you. I combined 2 steps in one when I went to here. So this is my first integer, and remember, that is not our solution. That's just part of the solution. That's our first integer, minus 8. Our next one would be plus 2. It would be minus 6. Our next one would be plus 4. That would be minus 4. Okay, that is our answer. Minus 8, minus 6, and minus 4. Okay, turn to the next example, turning your page over to 288, example 80.2. Find 3 consecutive odd integers. Okay, there's that small word, that it's the odd integers. We want 3 of them, so our variables are still going to remain n plus 2, and n plus 4, such that the sum of the first and the third, okay, we have a sum of the first one, n, plus the third one now, the third one, n plus 4, okay, is 7 greater than, and remember the trick I said, let's just write it as a greater expression, since that's the way they worded it. The third is 7 greater than, so I'm going to put a greater symbol and park that 7 on top of it right now. We'll deal with it later, okay? Is greater than the second decreased by 18. And so what is that? That's the second term, n plus 2, decreased now by 18. Okay, so now we have a subtraction. Okay, so now let's go back and express it as an equality. Okay, what it's saying is this side right now is 7 greater. That's the way the expression reads. This side is greater, this side is less. So we got to do something with that 7. We either send it to this side and subtract it to make it equal, or we send it to this side and add it, okay, to make this side larger. Let's see what the book did. The book went ahead and sent it to this side to make it smaller, this side smaller, okay? I'm going to do the opposite. I'm going to send it to this side over here, okay, to make it larger, because I don't like to introduce a negative sign unless I have to, okay? So what will we do? Then let's look at, we can get rid of the parentheses if they are not bothering us, and over here this becomes n plus 2 minus 18 plus 7. Okay, so then the drill will be the same. Go ahead and combine the variables on the left side, the ends, and the numbers on the right side, and solve. I'm not going to do the math to keep this video a little bit shorter. Let's go to the next example. So I just wanted to point out what side you put that on, the unknown number, because the statement was expressed as an inequality. It doesn't matter. What matters is, do you add it to the side, or do you subtract it? Okay, and your greater than or less than symbol should help you decide what you need to do there. Okay, so example 80.3, find 4 consecutive odd integers. So now our term, we have 4 of them. We have n plus 2, we have n plus 4, and we have n plus 6. Okay, we have 4 of them. Okay, and they want to know, find 4 consecutive odd integers such as the sum of the first and the fourth. So we have the sum of the first term, n, and the fourth, n plus 6 is the fourth term, the fourth number, okay, is, and so that's our equality sign, is 25 greater than the opposite of the third. And I'm sorry, we don't have an equality. They said it's 25 greater. The sum of the first and the fourth is 25 greater. So I'm going to write that greater sign and put the 25 up there to park it for now. It's greater than what? The opposite of the third number. The third number is n plus 4. But we don't want that number. We want the opposite of, so we're going to put a negative in front of that term. Okay, what do we do with the 25? Well, what side is bigger? Right now this side is bigger by 25. We would need to add 25 to this side. Now in your book, they decided to send it to this side, the left side, and subtract it. I'm going to do the opposite. I'm going to send it to the other side and add it. Okay, so I simplify on this side and I introduce my equal sign. Okay, I'm going to send the 25 over here. Excuse me. Now, this is the importance of indicating your variables in brackets, because now what we have the opposite of the third expression. Okay, to get rid of the parentheses, the brackets, I have to apply the distributive property here. And I notice when I do that, it becomes a minus n and a minus 4. Okay, then I add my 25. Okay, so if I had not had that parentheses there, and I just expressed that as n plus 4 carelessly, and then I said, oh, it's the opposite of it, and I put the opposite sign, okay, I'm in big trouble now because I've just made it minus n plus 4. But keep the parentheses in there, okay, that keeps you out of trouble. Now, here, it wouldn't have got us into trouble, but it's good practice to continue using the parentheses, okay, and then if it's not needed, and you can easily take it out in the next step, take it out. But while you're writing it out, keep them in, and then take a step back and see, okay, do I need those parentheses? Now I take them out. Well, here I did need the parentheses to make sure I applied that opposite sign better, okay? So this is the expression, okay? So I'll just solve it real quick. I'll get a 2n plus an n from the other side. I'll get a 3n on this side. I'll get 25 minus 4 is 21, okay? I'm going to add or subtract further another 6 from that, okay? I'm going to subtract a further 6 from that. And 21 minus 6 will be 15. Okay, so then I get an n equal to 5. And again, that is my first number. That's 5. The next one would be 7. The next one would be 9. The next one would be 11. Okay, this is my answer for that problem. Okay, so I hope that helps. Sorry this video was a little longer. I just want to make sure you get these problems down. Like I said, they're going to be around a long time here in Algebra 1 and Algebra 2. Shoot an email with any questions or a text message. See you for now.